Good afternoon, everyone. I would like to begin this presentation with the cautionary code that your immune system is under your neighbor's control. I know this is a weird statement, but typically we don't want anything to be under our neighbor's control, but unfortunately our immune system is. Uh, Let us see who could possibly be that neighbor who is speaking with your immune system. Based on the title, you can say it's geography, but it's not. Let's see what it is. This is pretty much the content of what we are going to see in this presentation. The context behind this topic is that as we age, the capability of our immune system to function properly declines. This age-related deterioration in the immune system is known as immunosenescence. We all know that there is health and mortality wise differences with respect to place where we live in the US. This could be due to many factors like society and environmental conditions that can indirectly affect our immune system. This leads to decline in the immune functioning, which is in turn associated with mortality and morbidity. So we are interested in seeing if there is any place-based differences in the immunosenescence. Basically, we will look at place-based differences from different perspectives. First one is the geographical region. Next one is neighborhood setting. And we will also be looking into neighborhood socioeconomic status. I will get back to NSES in the upcoming slides. Before getting into the analysis, I will give a brief overview about our immune system. We all know that it is a complex biological system where multitude of different cells interact with each other and provide a thorough defense. Basically, we have two kinds of immune cells. One is the innate immune cells, something that we are born with. They are non-specific. So all of us have similar capabilities in terms of innate immunity. The other one is the adaptive immune cells. These are the antigen-specific immunity. So this depends on our previous exposure to foreign particles and infections. Neutrophils, NK cells comes under innate immunity, and adaptive immune cells are broadly classified into T cells and B cells. When a foreign particle enters into our bloodstream, B cells creates antibodies. This is a famous term. So antibodies will neutralize the foreign particle within the blood. But once if that pathogen or foreign particle enters into a cell, B cells can't do anything to it. In that case, T cells comes into action. Again, T cells are classified into two types. CD4 T cells are something that gives signals, plays some music, indicates that antigen is in the specific cell. On listening to this, CD8 T cells enters into the cell, destroys the antigen. So for CD4, CD8 and B cells, they also have subsets. The two major subsets are naive subsets. As the name indicates, naive subsets are like young children. They can adapt themselves according to the incoming antigen. So they are very flexible. Flexibility is always good. And the other one is memory subset. Memory subset is something that remembers the antigen and carry forwards that memory for an extended period of time so that if a similar antigen occurs again, it knows how to fight against it, basically. And we will be looking into these 6 specific components of immune cells because CD4 naive T cells is something that was shown to be associated with mortality in previous studies. And CD8 naive and naive we are also naive cells. So we care about flexibility a lot. So we want to look into that as well. CD4 central memory and CD8 central memory T cells are something that persists for a really extended period of time. It is a measure of your exposure to antigen for a longer period in the past. So we want to look into them. And IgD minus memory B cell is shown to be a risk factor for COVID associated mortality. So we are also considering that. And these are some key points based on previous papers. Lower CD4 naive and higher CD4 memory B cells is considered to be a marker of immunosenescence. And one of our previous findings on HRS, we had shown that 1% reduction in naive T cells corresponds to 0.7% increased odds of mortality. We might believe that immune system will only protect us, but if things goes wrong, they can also act against us, basically. We will be using health and retirement study dataset. HRS is a longitudinal study of older Americans, where special population like Hispanics, blacks, and residents of Florida have been oversampled to make the data nationally representative. Immune cells in HRS were measured using a technique called multi-parameter flow cytometry. Flow cytometry is performed on cryopreserved blood samples. The device that you are seeing here is the flow cytometer, which is used to measure the immune cells. After measuring the immune cell, we classify them into different groups based on the markers that they exhibit on their surface. This method is known as immunophenotyping. Previously, we had shown that using immunophenotyping protocol shown in HRS minimizes the impact of cryopreservation. After immunophenotyping, we apply a technique called gating to identify subsets again within the immune cell. So using gating only, we identify naive memory subsets. So this graph indicates the gating strategy. The here x-axis is the CD4 marker and y-axis is the CD8 marker. If some cell has more CD4 marker than CD8 marker, we basically categorize them as CD4 cells. Similarly, if a cell has more CD8 marker than CD4 marker, we classify them as memory T cell. Basically, gating is used to identify, used to separate cells of our interest from debris, and that's how immune cells have been identified in HRS. So after identifying the immune cells, our initial we wanted to see if immunosenescence vary place by place, and immunosenescence has an impact on immune cell population. So we wanted to see if the population of T cells and B cells has difference based on these exposure variables. I will explain about these in the upcoming slides. In HRS, the country is divided into 7 geographic regions. An interesting point to note is that we have 3 regions from the south: South Atlantic, Southeast, and then Southwest. This is the region-wise participant count in our study. Overall, we had like some 1,200 and something. I don't remember the exact number. And South Atlantic has the most number of participants, followed by Midwest. This dark bar graph indicates proportion of racial groups within each region. As we could see, we have no Hispanic white population, which is the blue bar in the southeast. And in southwest, we have the most number of Hispanic white population. And non-Hispanic white is shown to be the most populous group in each of the region. This bar graph indicates region-wise education difference. The purple bar are the people who dropped out of school. So Southwest has more number of school dropouts, approximately 25%. This multiple box plots indicates the distribution of age for smokers, non-smokers, and former smokers for each of the region. As we could see, the green box, which corresponds to current smokers, is well below the other 2 boxes, indicates that people who are currently smoking are less in age compared to non-smokers and former smokers. Besides looking at geographical region, we wanted to see if there is any specific zone in the United States that is defined based on health outcome. One such zone is the Stoke Belt. It's basically states from the south, but these states are shown to have higher incidence of stroke and other related morbidities. So usually Arkansas and Alabama would be a part of this Stoke Belt. We have excluded them in this analysis due to low number of participants. This is the count of participants within urban and rural neighborhoods within Stoke Belt and other states. As we could see, we have more number of participants from urban non-Stoke Belt states and least number of participants from rural Stoke Belt states. And we are defining two indicators of neighborhood socioeconomic status. One is neighborhood affluence and neighborhood deprivation. We compute them using factor analysis on these 10 census tract variables corresponding to education, employment, economic stability, and social status. In factor analysis, basically, we use the top two principal components that explains 95% of the variance. Usually, principal components are not orthogonal, which means they are not uncorrelated. So we apply varimax rotation and makes them uncorrelated. We name them neighborhood affluence and deprivation because they have factor loadings that corresponds to different things. For example, if I'm considering the census tract variable person population in poverty, one principal component has positive factor loading and other has negative factor loading corresponding to that. This indicates that these two principal components are capturing different aspects of neighborhood socioeconomic status. And they are represented in terms of quintiles in our analysis. This chart indicates proportion of affluent quintiles for each of the urban Stoke Belt combination. As we could see, the purple bar, which is the most affluent neighborhood, is more in urban zones compared to rural zones, and the more number of least affluent neighborhoods is more in rural zone compared to urban zones. This bar chart is the similar one, but for deprivation. Here we could see that participants from Stoke Belt have, for example, for urban Stoke Belt and rural Stoke Belt, we have more number of most deprived participants. They have the deprivation quintile of 5, and non-Stoke Belt participants have least number of have the most number of least deprived participants. So to identify whether our immune subsets differ based on previously seen exposure variables, we use multi-level linear models, linear regression mixed effect models, where we use census tract as a mixed effect. All the models are adjusted for the standard covariate adjustment. Here, the exceptional case is CME seropositivity and comorbidity index. CME stands for cytomegalovirus, which is a chronic viral infection. It basically aggravates the symptoms that you get due to some other sickness when your immune system is really weak. And seropositivity indicates whether the CME viral in your blood is reactive or non-reactive. Comorbidity index is computed by tallying the number of self-reported chronic conditions in the 2016 HRS survey. Moving on to results. So this bar chart indicates differences in the immune cell population with respect to regions. Y-axis indicate the mean percentage for each of the immune cell. On blue bar indicates CD4 naive subset, which is shown to be associated with mortality. And orange bar indicates CD4 memory subset. This red color bar is the baseline region for which against which we compare the other regions. As we could see, southeast and southwest regions have reduced mean percentage of CD4 naive T cells when compared to Midwest. And West Pacific region has more CD4 naive T cells compared to Midwest, and this difference is shown to be statistically significant, indicated by the star. Here the region with the most percentage and the region with the least percentage has a difference of 4. This 4% difference in turn corresponds to 2.8% increased odds of mortality. That is a notable number. And for CD4 memory T cells, we could see that Southwest has increased number of memory T cells compared to Midwest. This indicates that people are more prone to antigenic exposures in the southwest. This is a similar bar chart for CD8 T cells. We could see that blue color bar, which is CD8 naive, is higher in northeast and lower in southwest compared to midwest. And again, similar chart for B cells, though we could see some statistically significant difference, but in terms of mean percentage, this is not much. Now we will see whether is there any difference between the human cell populations between stroke belt and other states. As we could here, the baseline is non-stroke belt states. As we could see, the blue bar CD4 naive is less in stroke belt states compared to non-stroke belt states. And the orange bar CD4 memory is slightly higher and it's shown to be significant, but the actual difference is not much. This bar indicates urban-rural differences. Urban region is considered to be the baseline, and rural regions are something that we are looking out for the difference. As we could see, the mean percentage of each of the immune cell is approximately the same, so no significant findings there. Now we will see if there is any significant difference between the quintiles of neighborhood affiliation and deprivation. Here, least affluent quintile, which is the quintile 1, is considered to be the baseline. As we could see, as we increase up the neighborhood affluence ladder, we could see that more affluent neighborhoods have more CD4 naive counts, and it is shown to be significantly different for most affluent neighborhoods compared to the least affluent neighborhood. And for CD4 memory, though we have some finding, we couldn't establish any clear trend as we move up the affluence ladder. This is a similar chart for deprivation, and compared to the least deprived, we could see that the most deprived neighborhood has the CD4 naive, and there is approximately a decreasing trend as the deprivation level increases. Here we are looking into urban and rural differences between stroke belt, and we are considering urban neighborhoods within non-stroke belt actually baseline. When compared to this, urban regions within the stroke belt has decreased naive T cells, CD4 naive T cells, and increased CD4 memory T cells. Rural region within the stroke belt also has a similar trend, but due to less number of participants, it is not shown to be statistically significant. Since urban region within the stroke belt and non-stroke belt are shown to be different, we want to see if they have any difference based on the level of affluence or deprivation. Based on this chart, we could see that for each of the level of neighborhood affluence, the orange bar, which corresponds to urban region within non-stroke belt states, has more CD4 naive percentage than urban region within the stroke belt states. We could see similar trend for deprivation as well, though there is no statistical significance. Based on this finding, we could see that this decrease in CD4 naive percentage in the stroke belt state is distributed irrespective of the level of deprivation or affluence. Based on our results, we could infer that Southwest region differs significantly from the other regions, and we couldn't see any rural-urban differences in the immune cell population. Stroke belt urban areas have lower CD4 naive and higher CD4 memory. And based on socio-economic status, we could see that most affluent neighborhoods have higher CD4 naive and lower CD4 memory. This is a marker of good immune profile. So if you are in an affluent neighborhood, you might be having a good immune profile. This lower CD4 naive and elevated CD4 memory T cells that we are seeing for stroke belt indicates that participants from these regions exhibits a compromised immune profile compared to the rest of the United States. Though this aligns with the presence of lowest life expectancy rates observed in these regions, the light pink states or the states belonging to stroke belt. But assigning this difference only due to region is very superficial because there could be multiple factors that uniquely define this region. And this difference that we are seeing could be an artifact of those factors. So, in the future, we want to consider if there is if these factors might be a confounders in this association, and see if they have any complicated interactions, maybe second order or third order interactions that could possibly be a causal factor behind this difference. So we want to look into that. By overall, these findings indicates that geography and the socioeconomic status, which is what I meant by neighbors in the first slide, they could be a big neighbor, or even once we have data that is more defined in the county level or in a more smaller circular level, we could see that we might even show differences within a single state or something like that. So be it a larger neighborhood or a smaller neighborhood, which might have an impact on your immune system. So our future direction is that we will consider other possible causal factors like air pollution, heat, to see if they could be behind this compromised immune profile. And we also want to consider length of stay of each participant within their neighborhood, so that we could understand the temporal impact of this geographic location on their immune system. I would like to thank Inyang Choi, who helped me with most of the analysis, and then Jennifer Alshare for inviting me to this workshop, and my graduate advisor Bharat, basically for everything.
Our speakers need to be properly introduced, and while we do this, I'm going to wow you all with my multitasking skills. So our last session today is really more on historical data. We have 3 speakers, and our first speaker is Emma Zhang. Emma Zhang. I'm sorry, I don't know. I can't.
Everybody loves the website.
So Emma is an assistant professor in sociology with appointments as well in biostatistics and global health policy. Global affair. I'm doing this off the top of my head based on what I know about Emma. But Emma's research actually spans a lot of different topics, including families and households. She does research both in the United States and other countries like China. We're particularly interested in her work on health and aging, where she's done work trying to understand trends and differences across countries and also individual trajectories. I'm almost there.
That's impressive.
And I invited Emma to come speak because she's doing some really interesting work using some of the historical data available on HRS, although cautionary tale, it's hard to get access to data. But I invited her in part to tell us about some of her experience. But she's really starting to do very nice path-breaking work on geographic contexts, intersected with trajectories, health trajectories in this case focused on cognitive outcomes. I'm not going to read the rest of the stuff in her bio because I see her all day, but thank you very much for being here with us.
Thank you so much for having me today, and good afternoon, everyone. Today I will talk about trajectories with geographic context and cognitive outcomes in later life. So this is in collaboration with my 3 amazing student research assistants, Yang Li, Jason Long, and Xiao Lu. We know that ADRD, which refers to Alzheimer's disease and related dementias, is a major public health concern in the United States. ADRD are major causes of mortality among older Americans, leading to cognitive decline, disability, and high healthcare costs. So this figure shows the percentage changes in selected causes of death between 2000 and 2019. As we can see that the death related to Alzheimer's or ADRD doubled during this period, whereas deaths related to other causes nearly unchanged or even decreased. An estimated 6.7 million Americans aged 65 and older are living with ADRD in 2022, incurring annual national healthcare expenses of 345 billion. And the number of people living with ADRD is projected to increase to 13.8 million by 2060. There are significant geographic disparities in ADRD-related mortality in the United States, mainly concentrating in the southern and western regions. However, we don't know the reasons, and there are two major hypotheses. The first hypothesis, which the dominant one, is that while there's something going wrong in the south and in the west, that is really bad for people living there in terms of their cognitive health. While the alternative hypothesis is that people who have worse cognitive health, they self-select themselves to move to the west and the south. So we don't know which hypothesis is more true. So what do we know? From the literature, we know dementia prevalence was the highest in the south. And geographic variations based on early life residence or current residence, actually, we have evidence to show that both may matter. So for example, Topping et al. 2021 found that the people currently residing in the stroke belt have higher odds of dementia mortality after controlling for place of birth. On the other hand, we also have studies like Zachary et al. In 2023 found that people born in the south have higher odds of dementia after controlling for current residence. So there's some suggesting evidence that both may matter. However, there are several major gaps in the literature. First, we know relatively less about how place of birth and place of current residence jointly shape cognitive outcomes in later life. That is, well, what if a person who was born in the West and moved to the South versus a person who was born in the South and currently living in the South, and whether the cognitive outcomes of these two people will differ. And second, we know less about how differential residential contexts across the life course shape cognitive outcomes in later life. More broadly, right, not only the birthplace and the current place, what about the trajectories of residential contexts? How that would matter for people's later life cognitive outcomes. And finally, we also need a more global measure of cognitive health that considers both mobility and mortality. Previous studies mostly focused on either the prevalence of dementia or ADRD-related mortality. So some of the measures like life expectancies related to ADRD or healthy life expectancies actually can nicely combine the two aspects together. So the major innovation of this broader project we're doing is to examine the trajectories of the exposure to geographic contexts. So for example, if we have a person A and this person lives in 4 states during his life course: Connecticut, New York, Pennsylvania, and Ohio. And the x-axis is age. And most studies focus on either the birthplace, which is Connecticut, or the current residence, which is Ohio. And we propose a life course trajectory perspective of individuals' residential context. That is, we view the whole trajectory to study its impact on later life ADRD risks. So why is it important to study trajectories? Well, theoretically, individuals are embedded in multiple geographic contexts along the life course, and contextual exposures in early life have long-lasting effects on later life health outcomes. And also, what you live at this moment may have consequences on what you live next, right? So looking at the trajectory will give us a full picture of a person's geographic context, and further highlighting the importance of sequencing, duration, and timing of residential exposures. So I will talk more detail about these 3 elements. Okay, so our project was founded by the Network on Life Course Health Dynamics and Disparities in 21st Century America as a pilot grant, and we have 4 stages. And today I will talk about the first 2 stages. But due to it takes a long time for us to get residential history data from HRS, so we haven't got access to it, although we submitted application last year in October. So I will not be able to present any results for stage 2, but I will talk about our plans. So in our stage 1, we want to examine how birth region and the current region of residence jointly shape ADRD-related life expectancies among U.S. older adults. And we only use public HRS data, specifically the RAND longitudinal file and the Langmuir classification of cognitive function. So we use a left table approach to calculate life expectancies. Our dependent variable is transitions in cognitive impairment status between adjacent waves. We have 4 states: normal, cognitively impaired but not demented. We refer to as CIND, and demented, and the last state is death. And our key independent variables are regional birth and regional current residence, which have 4 categories: Northeast, Midwest, South, and West. And we also control for a variety of social demographic characteristics, including age, birth cohort, sex, race, ethnicity, education, and marital status. We apply this basic multi-state life table method developed by my collaborator Scott Lynch and myself in 2022. And this method allows us to calculate the expected years and the proportion of life to be spent in different stages of cognitive impairment prior to death. A little bit more about this method because it's amazing and we want everybody to use it. So compared to alternative life table methods, our methods can handle a large number of life table states. In our case, we have 4 states. Most life table methods can only handle 3. And it can also incorporate states that can't be returned to once left. So for example, if someone was diagnosed with dementia, this person cannot return to a normal state. At least for now, there's no treatment for dementia. So most left table methods cannot handle this kind of state, but our method can. And third, our method can handle sparse cells that often arise from complex state spaces with sample data. So for example, there might be a very small number of people transition directly from normal state to demented states. Typically, people go through this mild cognitive impairment, say CIND in our case. And our basic method can better handle this kind of small cell sizes. And then finally, it is computationally more efficient. We have our package, and we welcome everybody to use it, check it out, and provide us with feedback and questions. Okay, so first, let's take a look at the distributions of birth region and current region combinations. So I don't think people have provided this information before, so it's amazing that over 70% of respondents remain in their regions of birth in their later life. Among those who migrated across regions, most moved from the Northeast and the Midwest to the South, while some moved from the Midwest to the West, and some from the South to the Midwest. I think it makes sense because the West and the South, they're relatively warmer, so older adults maybe would like to move there when they get old. And this figure shows our results estimating the expected years to be lived without cognitive impairment at age 50. And the left panel are for males and the right panel are for females. The y-axis represents the 16 different combinations of birth region and the current region. And the confidence intervals are 84% confidence intervals because in the statistics literature, if you plot the 84% confidence intervals, you can directly eyeball the differences. So basically, if you see 2 bars there, they don't overlap. That means they are statistically significant at the 5% level. So it's just for visualization. We can see that, well, amazingly, men who were born in the South, regardless where they currently live, tend to spend fewer years without cognitive impairment at age 50, ranging from 12.6 to 13.9 years. Well, for women, it's a different picture, slightly different. So women who were born in the South or the West, on average, spend fewer years without cognitive impairment at age 50, ranging from 18.1 to 19.2 years. So it's really not about where you currently live. It's really about where you were born. So let's look at the results for expected years to be lived with dementia at age 50. So again, we found that men who were born in the South or the West tend to spend longer years with dementia at age 50, ranging from 3.1 to 3.4 years. While women who were born in the South tend to spend longer years with dementia at age 50, ranging from 3.4 to 3.6 years. Well, people may ask that, well, what if the results are affected by the regional variation in the total life expectancy? Well, what if we calculate the proportion of life to be lived in each of the cognitive stage at age 50? It turns out our results still hold. So for men born in the South, consistently correlates with the smallest percentage of life remaining without cognitive impairment and the largest percentage of life remaining with dementia. And for women, born in the West correlates with the smallest percentage of life remaining without cognitive impairment, while born in the South correlates with the largest percent of life remaining with dementia. The main takeaway, so our results suggest that early life residence has long-term effects on cognitive health in later life. So it's more about where you were born, not less about where you currently live. So from a policy perspective, if we want to improve cognitive outcomes, some kind of early life policy interventions are more needed compared to policies directly targeting on older adults when they are old. And then we also found that born in the South or the West is particularly associated with worse cognitive outcomes. So this also speaks back to our previous two hypotheses. So basically, we found that the selection hypothesis is less likely to be true. So more likely, there's something going on about the South and the West in terms of institutions and policies. Okay, so now move to the second stage, which is more exciting. We want to examine how trajectories of geographic context shape later life cognitive outcomes. And there are so many contexts. And so we were thinking about which kind of contextual variables we should focus on. And then we were thinking about, well, why people move. Most people move because they want to have better opportunities, right? So people mainly move for better access to education, welfare, protection, and job opportunities. So therefore, we decided to focus on the upward mobility context. Well, this is emerging literature, and existing research has shown the causal effect of place on children's educational achievement, mostly from economist Rothschild's work. However, when it comes to health outcomes, the causal effect of place is more complicated. So some of my work actually shows that it depends on which group of people you are looking at, and also depends on what kind of health outcomes you are looking at. It doesn't, living in a high opportunity place does not always improve your health outcomes. Well, in this project, we focus on 3 key measures at the state level. The first is educational spending, the second is policy liberalism, the third is social safety net. So policy liberalism and social safety net are actually available in the CDR. But we also matched with the external educational spending data set because we can actually trace this variable back to the 1950s, which allows us to actually capture the geographic context in childhood. While the policy liberalism and social safety net, they only started in the 1980s. So for a lot of the HRS respondents, we cannot trace back to their childhood. Well, theoretically, educational spending matters because high quality public elementary and secondary education boosts material, psychosocial, and cognitive resources. In terms of policy liberalism, liberalism involves greater government regulation and welfare provision to promote equality and protect collective goods, and less government effort to uphold traditional morality and social order at the expense of personal autonomy. And for social safety net, cash assistance and in-kind benefits lessen the determining force of social origin on social mobility. So these 3 measures all capture upward mobility context. The research gap is a little investigation has been done on how upward mobility context in early life may affect cognitive outcomes at old age. And our research objectives first is to identify distinct patterns or trajectories of upward mobility contexts characterized by state-level educational spending, policy liberalism, and social safety net. And second, we want to examine the association between different trajectories of context and cognitive outcomes in later life. So we use public HRS data as well as cross-weave childhood health and family aggregated data and life history and health survey to capture some of the childhood control variables. And then we also use restricted HRS survey, which includes the residential history state level data, which gives us the everybody's like residential histories, not everybody, I mean, people's residential histories from birth. And then we also use the state policy and politics database for the policy liberalism and social safety net policy. So educational spending variables, we get them from the National Center for Education Statistics. So this is the sample flow chart. So we haven't got the residential history data, so it's not complete, but we plan to start with all HRS participants from 1998 to 2020, and then we restrict them to people who participated in the life history mail survey, which is about half of the people. And then after we get residential history data, we're gonna also do some other restrictions. And then our dependent variable is all cognitive outcomes. We have two. One is a continuous cognitive functioning, which is the sum score. The second one is a categorical variable measuring, which is more clinically meaningful, measuring whether this person has dementia or not. Just to give you an idea about the states of residence, so this is the data format from HRS. So for each of the residents, respondents are required to write about their start year and end year. And this data was collected in 3 stages. It's now all in one. So that's why they have the 2015 and 2017 version. And then our state level upward mobility context, as we mentioned, includes three variables, and we will conduct analysis separately. And I'll skip this because of time limit. So yeah, basically I want to show you some of the trajectory stuff. So this is an example for the data format we have. So for each person, we have the start year and the year of each of the state they live in. And then we have their educational spending quartile, 1, 2, 3, 4. And then we could also visualize their residential histories using this figure, right? And then different colors represent different quartiles. Okay, so why we should study trajectory? So let me give you one hypothetical example. So for example, we have this person A who lived in 4 states, Oklahoma, Arkansas, Pennsylvania, and New Jersey, right? And then we have this person B who lived in exactly the same 4 states, but this person B just lived in Oklahoma for much fewer years. So what is our prediction? So based on our social theory, we predict person A will have worse cognitive outcomes than person B because duration may matter. So Oklahoma has basically relatively bad upward mobility context, and person A lived in Oklahoma longer. So we have this kind of prediction. If we only look at the birthplace or the current place, we will not be able to capture this. And then sequence and the timing may matter too. So let's consider person A, who also lived in these places from New Jersey, Pennsylvania, Arkansas, and Oklahoma. So this person, for some reason, over time moved to worse and worse places. And person B, on the opposite, from Oklahoma moved to Arkansas, Pennsylvania, and New Jersey. This person B moved to better and better places. So what is your prediction? Who will have better cognitive outcomes later in life? Raise your hand if you think it's person A. Okay. It's actually ambiguous. Why? Because, well, if you think about sequence, right? Of course, we have reasons to believe that people who move to better and better places, they will have better cognitive outcomes in the future. But then, if you think about critical period theory, if you believe the birth state actually matters the most, right? Person A actually was born in a much better state compared to person B. So it's ambiguous theoretically. That's why we need empirical analysis to tell us. We plan to include a bunch of K covariates in the childhood and some social demographic covariates. And analytical strategies, we plan to use sequence analysis to compute these similarities between certain interval sequences based on education spending, respectively. And then we use cluster analysis to group individuals with similar trajectories into unique trajectory groupings. And then we will use linear regression or multi-level regression to assess the association between trajectory groups and cognitive outcomes at older age. Okay, so finally, just very quick, our next stage 3 is to do a decomposition analysis to examine which specific contextual characteristics is most responsible for the observed regional disparities in later life cognitive outcomes. And then stage 4, we're doing this very big model trying to see how neighborhood, county, and state level contexts interact with each other to shape cognitive outcomes. That's it. Thank you. Anyone has questions?
Any questions? I'll be sending the mic.
Thank you very much for the great presentation. I really enjoyed the last part of the presentation where you talked about the geographical, how using each region kind of matters. And you briefly mentioned whether it matters more to live in a good area in the earlier stage or the later stage. So that was very fascinating. But also, would you look at the urban versus the rural area? And also, depending on the stage of the life, different people live in different regions, such as you might be more in the urban area where the more educational facilities exist, but then later in life, you might move to suburban area. I wonder if you take that into consideration. Thank you.
Yeah, thank you. I think this is a great point. I think that so many things can be done using our approach. Of course, you can look at trajectories moving into urban area and the rural area, right? And then in our analysis, we could simply control for it. But I think there's so many contexts. Every variable in the CDR, you could actually do a similar type of analysis and look at their trajectories. I think that's a good point.
Thank you. Excellent presentation. And I'm not sure if I followed. So is each one of those sections that, like how you pointed in is there some kind of weighing for the different ones? And the reason I'm asking is because, for example, like, the childhood years when you're in school may weigh more than the little period before that, or
Yeah, so that's a great question. So that's I think this is an empirical question, like whether childhood matters the most, or whether actually every age point during childhood actually matter to some extent. So that's why once we have the data, so we can actually look at like whether person A or person B have better cognitive outcomes, and then we can have a better sense about whether the critical period theory makes more sense or the sequence of trajectories makes more sense.
okay, got it. So it's like backwards. So you're looking at it after you create all this.
Yeah, so we're trying to do some empirical research to support theory, to tell us which theory actually makes more sense in terms of cognitive outcomes.
Thanks, Emma. I actually think you might be one of the first people using the new residential history data out from the HRS. So right now the state data are out, eventually cities will be out, and eventually we'll have residence level data out as well. Okay, so our next presentation is from Matteo Farina. Matteo is an assistant professor in human development and family studies at the University of Texas at Austin. He actually did his PhD work here with Eileen Crimmins. Prior to that, he was actually here as a graduate student finishing his dissertation. That's when I first met him many years ago and introduced him to this historical mortality data. that he used in one of his dissertation chapters, which he hasn't published yet, and this is a cautionary tale for you. But I invited him to this workshop in the hopes that we can jumpstart the publication process of what I always thought at the time was a very interesting study. I actually think, despite Emma having to sort of pivot a little bit, your talk fits in very nicely with the other two talks in this session. Is this all okay on the Zoom?
Check his microphone. Can y'all hear me? No problem. All right, so I'm just gonna. So yeah, it was not published yet because I also thought the idea was crazy. Y'all can tell me if it's a crazy idea or not. But there's nice ways that. So I know I go back and forth, and you'll see this throughout. In the schedule, it says infectious diseases. I go back and forth. I'm not really sure. I don't want people to think I'm actually looking at infectious disease exposures of individuals or a larger context. And then there's also maternal mortality in here. So I'm going to be looking at early life, state level pathogenic environment and later life dementia risk. And today's talk, I really have three objectives. The first is really to discuss the need and use of historical context data when we think about life course trajectories and pathways, and especially when we think about aging processes. Early life is really important for development, right? And we can't sometimes people forget that when we think about aging. So it's not just about changes, but also where we start from. I'm going to talk about the creation of the pathogenic environment at the state level and linking it to the HRS data, which hopefully eventually will be a public resource. And then I'm going to provide a sort of case study in which I was using state level pathogenic environment to predict dementia incidence, and sort of what was kind of a surprising result, and how strong it was actually. So early life origins of later life dementia, and also really when I think about this, older adult health more broadly, right? So there's ample evidence on early life origins of later life dementia risk. For dementia, we can think about two sort of things that are really important. We're thinking about brain development and growth, right? So we're actually thinking about the organ system itself, sort of issues that are changing structure and function, and the way that impacts you overall. And then we're also thinking about cognitive development, right? So this has largely been focused on sort of education and the educational environment and experiences that really bring up your level of cognitive development, that then the ideas is carried forward and helps kind of build some resiliency into maybe some pathological or neurodegenerative changes that might be occurring. So your cognition remains the same. So early life can really be thought about as a critical or sensitive period. And here I like to use sensitive because I think there are some changes involved, at least in these later early life period, not necessarily infancy. And then, but more studies, like I was mentioning before, when looking at dementia, they're really focusing on educational attainment or childhood poverty, SES, those type of conditions. We did and do have very limited but growing information on sort of infectious disease exposures, things like that. And I'll talk to you in a second as to why, especially when we think about retrospective data. So pathways linking specifically pathogenic environments to cognitive health. I really was thinking along sort of two different types of pathways to kind of be thinking about. First is direct pathways, brain development. There's been numerous studies that if you're exposed to some sort of infection, right, your brain's got especially as you're growing and development, your body's going to be trying to use that energy to fight off the infection, right? Which might take away from some of your other organ systems as well. And there could be chronic local inflammation that sort of gets set. Inflammation is actually, at least in the HRS, one of the better predictors for looking at dementia status, later on in cognitive status in general. So those are very important. And then indirect pathways. If you're sick more often, you're less likely to go to school. So educational attainment might suffer, your grades might suffer, you might not be getting as much cognitive development involved. Your socioeconomic status as a result also might suffer as well, especially if you're sick. And then there's also linkages to cardiometabolic conditions such as diabetes and heart disease and stroke, which also are known risk factors of dementia itself. Slow down just a little bit. I am Argentine, talk too fast. So challenges with assessing pathogenic exposures from retrospective data. So the HRS does actually ask respondents if they had childhood diseases. However, when I was looking at this data, and I think it's admirable that the HRS collects it, I'm not sure how much I trust it given some of the prevalence and some of the weird actually associations I was finding with different health outcomes. So they do ask about measles and a couple others. So there's an issue in terms and concerns in terms of misreporting exposures or experiences that they had. People can't recall it, or if they say they had one thing, but really it was a different thing, right? Those are all ample concerns, especially when we think about older adults, in which we never actually collect this information from the get-go. And then it might not capture the pathogenic environment more broadly, right? So someone to report to have measles had to have had measles or like some sort of actually, so it had to have been diagnosed at least, or they've had to have like, they become symptomatic. But if there's an area, which I'm going to argue here, if there's an area with large amounts of measles exposures, influenza, things like that, that area probably has more pathogenic exposures in general, early childhood. So creating the state level infectious disease environment context data really has sort of 4 different steps. And I'll show you kind of going back and forth in this, but basically in download the data, there's online database. We're trying to digitize tables right now with many collaborators because we're kind of going back. What I'm showing you today is actually from the Laris Munis data set, which is publicly available. You just need the restricted HRS to kind of connect it.
From the Grant Miller data set.
Grant Miller? Okay. Thank you. Grant Miller data set, but I took it from a Laris Muni study and site that they connected me to. And then we wanted to examine missing information. There's actually a photo, if you stick around in our wake towards the end, there's a photo of me and Eileen and another graduate student that we're actually kind of doing this eyeballing it sort of across different maps, which I'll go into in a second. So what we kind of did was examine the patterns of missingness at state level information. So there was consideration of urban rural populations. We know that urban populations might have actually had more infectious disease exposure between, especially back in the 1920s, 30s, and some of those changes. Seasonality, right? We know, I mean, especially with COVID, I think we're all aware that seasonality can impact the way in which people are exposed, and then geographic proximity. So states that were similar in those sort of conditions as well as close to each other, we sort of kind of gave the values of the states and surrounding or averaged it as well. So you can impute or substitute missing values. I think in the next iteration of this, we're going to be trying to actually use some other sorts of approaches like PCA approaches, also some imputation approaches to it. And then I created a flag for substituted when we just kind of were eyeballing it. The imputed data also created a flag as well. But the things that I will say is most of these results were robust too. We're kind of controlling for whether or not we imputed the information or substituted the information. And the last step basically is the creation of data with year and state information, which then we can merge into the HRS, which I'll get into in a second. And the two sort of the criteria that we used was year and state of birth or schooling, because I did it both ways. So we took the year and birth and merged that, and I also took the year and schooling at age 10 and merged that because there were some changes, like approximately 10%, there were some changes in between people where they're born and when they went to school. But I wanted to see how sensitive was when what part of the early childhood period we're picking. And it wasn't sensitive, the same result essentially. So creating the state level pathogenic environment construct, we use the principal components analysis to really create a latent construct. This was also verified using conformatory factor analysis as well. We're getting the same sort of result. And the idea here was that the state level pathogenic environment would be represented by the scary skeleton in the middle, right, because this is mortality. And then you have 5 different mortality conditions, which were age adjusted by the state and by the year, which were diphtheria, influenza, scarlet fever, maternal mortality, and tuberculosis, which we also know impacted children and death, in particular among children, greatly during that period, especially before, right, the sort of widespread use, invention and widespread use of antibiotics and vaccines eventually. So just to give you an idea of what the raw data looks like, so I think it's always a good idea, and this is kind of what we're dealing with right now from basically 28 to as far as we can go, which it will be in the 60s, which is basically, this is California, and it says all causes. The first row, which I couldn't kind of pull because it's a huge with each one of these states, but this first part is the number of total deaths in that year, and these are the different months, which I don't care about the months, and those are the number of total deaths that are reported within each of those conditions inside. So we're sort of in the process of digitizing that right now, or going to be in the process of digitizing that in the next couple months. And then to give you an idea, kind of alluding back to those maps, inside of the missing information problems that we have because of the differences in state registry information that was collected during this period, and obviously not everyone was a state yet, nor were they collecting the registry. So in 1921, ignore the 0 does not mean 0, the 0 means missing. everyone should have some information on 1921, which is this map. So basically what you see is there's a bunch of, we have all the information, right, for the Northeast, some for the West, a lot of the South and Southwest were actually missing information. And then with 1934, we actually get more information, almost actually get full information across all states for every year. So the only reason I'm pointing this out is because what we eventually ended up doing with these states is we were thinking about, okay, Alabama's probably close to Mississippi. And then when Tennessee came in, we kind of looked at how geographically close they were and also their rural urban status and kind of just substituted this number to Alabama for the time. And then also, which I wanted to kind of point out, which is I think is a benefit sort of from this data, we can think about moving forward in cohorts. This type of study might not actually be as valuable later on, given that the changes that we're seeing in state level, right, changes in diphtheria related deaths. So 1920, right, these are the states, the box plots. So you can see, right, there's a lot of variation, it's pretty much high. And as you continue, it kind of gets lower. So there are cohort changes, right, in terms of exposures that are going on. Those were also adjusted for, which I'll talk about in a second, which were fine. They didn't really. So the principal components analysis for the state level pathogenic environment. So the correlations for infectious disease mortality range from 0.48 to 0.78. Actually, more were in the upper end range of that. It was actually maternal mortality that had the lowest correlation across those infectious diseases. Right, but given that they were highly correlated for the most part, we thought this was a good idea to actually pursue. When we put it in through PCA, we got an eigenvalue above, way above 1 at 3.78, and that was the only component that was above it. So suggesting that there was one component, which in this case was confirmed with factor analysis, which also said one factor was pretty good. No other components reached above 1, right? So we kept it. And then the component explained between 43 and 55% of variation across each of those individual state pathogenic environment conditions. So the smallest was actually for diphtheria, and the highest was for influenza, to give you an idea of how much it's explaining when we're looking at right to predict back on the state. So creating a categorical measure. Given that we're using PCA, and I was really thinking about sort of relative differences across states, and I wasn't actually caring too much about the exact rate, and we couldn't get that from PCA, we thought it'd be actually useful to think about 4 different categories, which is low, moderate, high, and high. And what I have in this table is supposed to kind of show you how the disease is looked across those different quartile ranges. So this is the first quartile, which is the lowest, right? For maternal mortality rate, we have 1.62. Well, right, it's 162.3, right? And then it goes down to scarlet fever at 0.2. And then the rates actually go up, right, to about 750 and then to 3 for scarlet fever, and kind of what is expected in the differences rates. But the thing I wanted to point out is that it's a relative measure, but the disease is not evenly distributed. So when we think about the quartiles, we shouldn't think that it's the same amount of increase. In fact, there's a 4.6 to a 15 times rate increase in the fourth quartile compared to the first. So this is actually a really infectious environment up here that we're really talking about, that 25% of the people we're living in, essentially, at some point. So when we're linking the state level infectious disease environments to HRS, this is largely done through the detailed cross-wave geographic information file. This was actually in the cold room just down the hall. We link the individuals through year and state that they're born in, or in state that they lived in age 10. Once again, I just did this for both just to make sure, right, that the findings weren't going to be sensitive to which one we were choosing, since we had both pieces of information. For this study, we actually excluded foreign-born HRS respondents, right, especially because the state in which you're born in is not going to be there. And then there's some, which I just wanted to point, there's some migration that's actually occurring across the states. For this analytical sample, I believe it was about 8% that we're changing. That might differ for the larger sample to look at, but right, we were limited to what we had. And then we pretty much linked across most respondents. So now I want to kind of bring us back to, I told you about how we create the data and what we're thinking about and how we're using it. What I want to bring us back to is the early origins of cognitive health in later life and what kind of inspired the need for this data and the study. So most early life conditions have a major impact on cognitive health. We've seen this in multiple different studies in which, especially educational environment, is being sort of carried forward. But there's both indirect and direct pathways. And this is just from a conceptual model That was published in 2010, but the idea is that child education leads to cognitive development, which then impacts your dementia risk, but that can also go around, right? Cognitive stimulation, which could be your jobs or places you live or activities you participate in, right? But it can also go through different types of vascular pathology, and then also come back. And the whole point of this is most of the work has been on child education and its link. We've seen this also with the, what's it called? Is it PAC? What Jennifer showed earlier, when we look at the modified risk factors for dementia, from the Livingston study, it was really focused on child education. But other aspects might also impact brain development. And here we were thinking about early life course exposures, especially in terms of pathogens, and thinking about health inequalities, right? And we're thinking about inflammation is one of the ways that this could be happening, which is one thing I want to actually be looking at, is how inflammation is tied to this, and a couple others. So this was sort of the conceptual model that we're looking at. Ignore the racing on the bottom, but they are race-specific pathways. I'm not going to go into that for this talk in particular, but the idea here is that you have child different conditions and they have education, right? And then you have child epidemiological environment, which pathogenic environment in this case, right? And it can impact your education, it can impact your adult cardiometabolic conditions, and it can impact dementia itself. And we're kind of testing out different pathways that might be emerging from this. So we use the HRS, right, which is an actually representative study of older adults in the United States. It oversamples Black and Latinx older adults, which are more likely to experience a dementia incidence onset. So that's very important. Collects extensive demographic health and health behaviors, cognitive as well as life history information. And then the definition of dementia, which we can go into later, but I don't want to spend too much time on it. The idea is that we just defined it as not having dementia. So that could actually include cognitive impairment without dementia to having dementia between 2 consecutive waves. We also did some limitations as that kind of continued to have dementia, as well as if you had dementia and then died, right? There's all different types of iterations. The findings and patterns are all the same, regardless of the way in which you are looking at the sensitivity of how you're defining the dementia onset event. So Analgopan was really just using a series of exponential hazard models predicting dementia incidence. The very first model, because I wanted to look at pathogenic environment, which I'll show you today. Actually, I'll show all of these models with the coefficient. And then we were looking at early life, including education as well. So adjustments after, including education, adult income, health behaviors, and chronic conditions. And adult income is adjusted for household size as well. So here are the coefficients. I will walk us through it a little bit slowly because I think I have a little bit of time. Okay. So I have a little bit of time, so I'll walk us through it very slowly. And just to kind of get this out of the way, it does control for age, race, ethnicity, and gender. Race and ethnicity was actually in another model. It doesn't actually really change that much as a control. And then additional, when I control for cohort effects, because of that change, right, that we're seeing, it also was still robust to that. So these patterns are, we looked at it multiple different ways. But the idea here is 0, right, is basically even, that line. And these are the coefficient values were actually plotted, and maybe show odds ratios, but I can tell what the odds ratios are to give an idea. And then anything above 0 is going to indicate a greater risk of dementia onset, right? So kind of what we expect, that second quintile, which is the second highest, goes up. And then you have a third, which is orange, and then the fourth, which is the gray, which is the very highest. And to give you an idea, sort of the magnitude of that gray is about the odds ratio is about 2.49. So it's about 2.5 times greater risk of having dementia onset if you were in the fourth quartile, which is the highest pathogenic compared to the first. After we adjusted for education and other childhood conditions, it kind of went down slightly, which was actually expected more. I was actually kind of surprised how robust this actually remained. And then it really didn't change all that much when you adjust for income, health behaviors, and cardiometabolic conditions. What was kind of surprising about this data was that it remained significant, and we thought that maybe like cardiometabolic conditions or education might actually have a bigger reduction, right, in its association. But it's as if we found this huge effect and kind of just left it in there, right? There was no way of explaining it. So that leads me sort of to where this was looking at was basically that early life matters, right? And it doesn't just matter for education, it also matters for childhood pathogenic exposures. And this actually points to when we're looking at dementia incidents, I start to actually think about this as an exposures model. There was some attenuation, right, with some pathways that might be confounding it or might be on the pathway of it itself. But for the most part, these two things were actually not changed in that study and remain significant and very significant. So considerations for using this information on state level pathogenic environment for aging and health processes. I do think about this as a proxy for pathogenic environments. It's not the experience itself. It would be great if we had data on the actual experiences, right, or we're able to collect biomarker information that might tell us if someone has had an exposure or how long ago that exposure was. State level, and also we have to be thinking about is state level versus smaller geographic levels. I do understand limitations of the data. It is historical data, right? It's like someone living in Chicago is going to have a very different environment than someone living south of Illinois in a more rural area. There's only so much we can do, but I just want to kind of point out that at least with the newer data, this is actually COVID in 2021, right? So that second surge that we had, we're seeing a huge amount of variation, right, within the counties with low and high risk. Everyone's really high risk because that was the surge moment, but I think what this points out is like we're taking an entire state and we're basically saying that the individual experience that we're averaging across it, but there might be significant variation. That newer data can kind of help us understand a little bit better. And then there's other potential confounders for other state level characteristics and changes. So the states that had better pathogen exposures, I could possibly see like having better policies overall, whether it's education policies, sanitation policies, those type of things that might be actually confounding. So it might be, I still think there's theoretical reasons to think about pathogenic, but there might be other things that we have to kind of consider. And then also consideration of cohort change. I think this is really important, especially when we think about population processes and what that means. So the nice part is these were not sensitive to that, but that was definitely a concern. If the high pathogenic environment was just capturing people from an earlier period, it wasn't actually the environment itself. So thank you. There's my email. Yeah, and this was supported definitely by the training grant that's here, as well as the K99 in resuscitating and working on it afterwards. And then collaborators near and far, most of them are actually near. One of them is just right over there and here. Where in this picture, just kind of a fun picture where we laid out all different maps, and I think we went over for a couple hours thinking about how to just substitute basically the values of neighboring states. And you took that picture. So.
All right, I don't know if the people online can hear me until you come closer. Okay, so our last speaker for the day is Katrina Walsman. She's the Lipitz Professor in the School of Health Policy, the University of Maryland on the School of Public Health. She's the Lipitz Chair in Health Policy and Professor in the School of Public Policy at the University of Maryland's College Park campus. She's also an affiliate of the Maryland Population Center. I asked her here today because she's been creating a different type of contextual data resource, which is focused on educational data in a historical context, something I'm sure Emma would be interested in using in the future. So she's another kind of data generator, although she's also published pretty extensively on the topic as well. Thank you, Jennifer. I know I'm the only thing standing between you and happy. I make this way. Also, I need it. So, all right. So thank you to Jennifer for inviting me to come and talk about this. I thought that I would spend most of my time actually just talking about the data and then give you a little kind of flavor of what I've been doing in terms of the research connecting it to dementia, or actually it's cognitive function that I've been looking at so far. So I just want to acknowledge my funders. This includes the Alzheimer's Association and the National Institute on Aging, and of course my wonderful collaborator, Jennifer Alshire, right over there, as well as my amazing data statistician, helper, thinker, Heidi Jackson, who is irreplaceable. Do not try and take her away from me. And then my two doctoral students who are really helping me with the data documentation and the code books and all of those other things. I think we've heard before some of the speakers talk about education as a key determinant of cognitive function and dementia. It's one of these most important protective factors against these outcomes, and it has both direct and indirect effects on dementia, including through some of these more proximal factors that occur in mid and later life. But it's important to think about the fact that educational attainment captures just one aspect of education, and that's quantity, and it leaves other aspects of education, including quality, unexamined. And that's an important limitation. I should acknowledge Callie Fisk here because she put together this beautiful figure for me. That there were a lot of changes that happened in the education system in the US over the course of the early 20th to mid 20th century. This figure shows some of the major educational policies that were enacted and court decisions that occurred during this time frame, and how they align with when the HRS cohorts were attending school, because the HRS is the data set that I use. And so solely relying on educational attainment masks these stark differences in the US education system. So that issue brought me to actually apply for some funding from the NIA. And so when we were funded, the goal of that grant is to examine the role of state and local educational quality on dementia risk. And so to accomplish those aims, we extracted over 50 years of state level data on 15 indicators I'll talk about in just a minute, reported by US states on the K through 12 public education system. And this includes data on 48 states and Washington, DC. So that's just a kind of a picture of what our historical reports look like. And we had to extract this data with the help of a lot of graduate and undergraduate assistants. So it was all manually extracted. And these are the measures that we extracted. They include several measures on revenue. So per pupil revenue at the federal, the state, and the local level. The percent of the revenue that came from these different sources, per pupil spending, average teacher salary, pupil-teacher ratio, the school term length, the average number of days that students attended school. We also have some information on the gender, like the percentage of teachers that were female, and then we have the total student population, the total teacher population. So these are some figures that kind of just give you a snapshot of how this is changing from 1920 to 1974 across many of these different measures. So the 1920 is in that lavender color, and then the 1974 is in the teal color. You can see that there's a lot more variation in some of those revenue measures that happens going forward. You have more revenue coming from the federal government and from state sources. You have a lot of variation at the local level as well. If you recall from that figure, there was a lot of things that were enacted in the 1960s, the Great Society programs that really invested in the US education system. So you see that increase there. You also see increases in per pupil spending and increases in teacher salary and declines in pupil-teacher ratio. And so this is just another way to kind of look at this. This is a national trend, and then the different colors actually show the different cohorts in the HRS when they were about age 10. So you can see that, you know, whereas like the ahead cohort had very low levels of per pupil spending, by the time you get to the late baby boom cohort at the very end, there's a significant increase in per pupil spending. On average, states or the US states are spending about $7,000 per pupil on education. And this is in, adjusted to 2022 data. So this is current dollar data. This is just another way to kind of look at this data on per pupil spending during this time point. The purple line shows the median expenditures in 1920, so that's our base year. And the blue line shows the 1974 median expenditures, so that's our end year. And so the lines start from 1920 and the arrows are the end point. So you can see that there is some significant movement that's happening during this, over this course of time. But there's a couple things that I should point out here. So if we take just like the bottom ranked states on per pupil spending, they don't really move a lot, right? The people that were not spending that much, or the states that weren't spending that much continue to not spend that much by 1974. These are all concentrated in the US South. And then if you look kind of at the middle ranked schools, you do see some movement happening there. So
These were states that were at the median in 1920. You can see New York, for instance, was the top spending state by 1974. Per people, you can see movement across DC, New Jersey, Massachusetts, etc. Oops, wrong one. Okay, so we also see this increase for salaries as well. We know that teacher salaries makes up a big portion of that per pupil spending. That's where schools spend a lot of their money. So during this period, we see increasing teacher salary wages. So by the time we're in the late baby boom cohorts, teachers are making about $65,000 in today's dollars. And this is, again, just another visualization of how this varies across states. Same kind of, the same thing with the purple is a median 1920 and the blue is the median in 1974. A lot more kind of changes happening there in the middle and the top here. Lots of people, lots of states there on the bottom, kind of just hanging out on the bottom, not spending that much money on their teachers. Okay. I do want to point out here that a lot of this movement in this middle is really happening in the Midwest. So again, you can kind of start seeing some regional differences that are happening across the US states at this time. All right, and then this is the pupil teacher ratio. And here you see declines that happen over time. There's kind of just this bouncing around that happens sometimes during the war years, and then towards the 50s, you start seeing a little bit more of a decline that then falls in the 60s and 70s of smaller class sizes. And here it's kind of a little bit of a harder kind of story to tell. I think some of this has to do with demographic changes. You see that on the top, some of those more rural states are increasing in terms of the size of their classrooms. So they're kind of coming down up to the median, whereas some of the states on the bottom in the South are coming down and having smaller class sizes. So both things are kind of happening, just depends on where you are in the US at this point. Oh, okay. Yeah. Okay. So all of that leads me to think about I should say, like the prior graphs highlight how much variation in state investment and public education occurred during this 50-year period, but how might this be related to cognitive function among older adults who were attending school during this period? So that's one of the driving questions in my research agenda, and it builds on this small but growing body of work that investigates the role of education quality on cognitive function and dementia. And I just highlighted some of the more recent studies in this area. And overall, in general, these studies tend to find that exposure to higher quality education is associated with better cognitive function. And these studies are using different types of samples, some from Northern California, the health and retirement study, the Wisconsin longitudinal study, and the New York, what is that, the white, I can't remember this, which one, what? The New York study, what's it called again?
White House?
Yeah, the White House study, and then one from Alabama. Sorry, I couldn't remember that one. All right. So the other thing that going into the study we were thinking about was, well, it might be those people who have the least amount of education, ultimately that benefit the most from higher quality school, because they have maybe less resources to draw upon from their educational attainment. And this study from Crow actually suggested that that might actually be the case. Oops, I thought that I had a little arrow there that I forgot about, but no, I did not. It's been a long day. Anyway, but they basically found that the strongest associations were really found among people who completed less than 12 years of schooling. So that kind of led us to our research questions for our study, which is that is state level educational quality associated with level and change in cognitive function? Does the association vary by educational attainment, and are the patterns similar or different for white and Black older adults, particularly because of where white and Black older adults actually grew up? We know that almost 80% of the Black older adult population prior to the 1950s grew up in the US South, and almost 60% after 1950s grew up in the US South. So there are these regional differences that are happening. So we took all of that data from that we extracted. We did a data reduction strategy and did some factor analysis. Basically, we took our 7 indicators that you see in this table here, and we smoothed year-to-year fluctuation by calculating the 3-year moving average of each indicator. And then we standardized each of the 7 indicator measures by year to ensure that they were comparably scaled. And then we did our factor analysis, and you can see here that we found 2 factors and that these explained about 84% of the variance. We kind of, we refer to the first factor more as like where this money was coming from, where's the funding source. And the second factor is more like the kind of the amount of resources that the state had for education. So you can think of these resulting factors as measures of relative state level education quality across states for a given 3-year period. And then we actually linked this data to the health and retirement study based on the measure that Matteo and some other folks have used, asking them where they lived when they were age 10. And so we linked that data to HRS. I should say this is some geographical distribution just at 3 time points here, 1921, 1948, 1973, to give you a visualization. And so just that whole chart of the different state level variation. But you can see that the lighter shades are less resources, right? They're closer to -2 standard deviations on this education resources scale, and the darker ones there are positive. So the Western states seem to have more resources for education, and the Southern states have generally less resources towards education. Those findings for the South are pretty persistent across this whole time period. All right, so after linking to the HRS, we ended up using data from the 1996 to 2018 HRS data set on cognitive function using the TICS measure. We looked at the total cognitive function measure. We also looked at the episodic memory and the mental status components of the TICS. We rate stratified our measures, our sample. So here you see white adults in the HRS. And then we looked at the relationship between state education resources and level and change in cognitive function. And we looked at how that varied by years of schooling. And you can see here that for white adults, we found that there were significant differences by level of education resources, but that they were mainly found for those who completed 12 or fewer years of schooling. And so the lavender and the dark purple are those who had 8 years or 12 years of schooling, respectively. The aqua is if they had 16 years. It was entered into the model as a continuous measure, but just for plotting these figures, we ended up plotting them at specific values that we thought were important. And then the low resource states are at the 20th percentile, and the high resource states are at the 80th percentile, and the high are the dotted lines, just so you can kind of orient yourself to these figures. So for Black adults, what we found is something slightly different. We found that higher cognitive function scores at midlife were found among those. So there were significant differences between those who had high or were residing in high versus low resource states as children. But again, only among those really with 12 or fewer years of education. You can see that the difference is quite large for Black adults for total cognitive function and episodic memory and for mental status. Almost 1 point on these TICS measures for those who had 8 years of schooling, and it's still quite significant for those who had 12 years of schooling. There's no difference that we found for those who had 16 years of schooling. There is a slight crossover effect that's happening there. You can kind of see that towards age 70, 65. What we kind of found was that in supplemental analysis that the Black older adults who grew up in states with low education resources were more likely to die earlier than those who grew up in highly educated resource states. And so we think some of that crossover effect is really due to selective mortality. So early life mortality, or not early life, but earlier mortality that's happening in the sample. So next steps. So we're also in the process of extracting data on the city data that's also available in these historical reports. We decided to only focus on the years 1943 through 1974 for a few reasons. We have to link this data using the Life History Mail Survey, and some of our prior research has found that the older cohorts are quite selective because they had to survive to 2015 to be in the Life History Mail Survey. The other issue that we had to think about was that the quality of the data wasn't as good and wasn't as consistently measured in these historical reports prior to this year, this 1943 year. So to simplify our lives and because of some of the selection issues, we ended up kind of picking this kind of year range for the data extraction. So there are fewer measures that are available at the city level, not surprising, and it's like unsurprisingly. So we're gonna have total student enrollment, per pupil teacher, average teacher salary, although that measure is missing data from 1958 to 1967. Pupil teacher enrollment, and then we have several measures of revenue, but that data is only available after 1968. So again, there's less data available at the city level, and it's more sporadic. In terms of the estimated timeline for the data release, because we do plan to release this data, our target kind of time frame for the state level data is to get the documentation and the code books ready for deposit, either to, I think we're thinking about ICPSR by the end of summer or early fall. We'll also obviously be able to have that in the HRS enclave because we are using it in the HRS enclave, so that will be available there. And then our target month for the city data extraction, because like I said, it's a lot more data. There's more than 50 cities in the United States. And so our target month is more like December 2024 to have that data extracted, to do the data quality control and to just assess the quality of the linkage, because we have to again use the Life History Mail Survey to link that data. We just don't really know what we're going to find until we start trying to link it. So provided that linkage is good, then it's probably going to be more like another year before we can release that data to users to use. So that is where we're at this point. I do want to kind of plug my network that I run with Pam Hurd and Sanjay Asana from Wisconsin. It's a network on education, biosocial pathways, and dementia and diverse populations. We give out pilot awards, we do workshops, and we do webinars, we all kinds of things. Anyways, join the network. There's a QR code because I'm trying to be fancy, and you can take that and that'll take you to our website, or you can just like put in the website at dimnetwork.com.